Hello everybody, this is going to be a short tutorial on how to use the DOP-C library. This is intended for people who, when learning new software, much prefer learning from a video than from any written guide. I will nevertheless still make the written guide available, and the URL is on screen and also in the description. Throughout this tutorial, I will be using a fresh install of Debian 11 on a virtual machine. This is to ensure that no matter what you have installed on your system, you should be able to get this working. One thing you simply must have is some version of a C++ compiler. I'm just demonstrating that I have it on my system here. I'm using G++, but any old C++ compiler should suffice. Of course, if you want to use DOP-C, you're going to need the files on your system, and the easiest way to get these files is to clone the Git repository. And that's what I'm doing right now. If we look at the folder structure of the repository, you'll see that other than licensing files and a README, the only file in this distribution is this DOP-C.hpp. DOP-C is a header-only library, which of course makes it easy to incorporate in your larger projects. If we wish to use this header file, we of course have to make sure that it is visible on our build system's include path. All I'm going to do really is append this include directory into my C+ include path environment variable. I'll create a new directory in which we'll put our example, create a new source file called foo.cpp, and naturally include our new DOP-C/DOP-C.hpp. Naturally, we also give this source file a main function. The first thing we should learn is how to create tables using DOP-C. We can do this in a variety of ways, but my advised pattern is the following. We're going to make a class and give it some public static members. Our first member will be of type DOP-C table. This is going to represent our table at large. Whenever we want to insert or delete rows, we will do so via this object. Our table will have a set of fields or columns, each having their own particular element type. Our table is going to have two fields, and I'm going to call one of them A and one of them B. Of course, I've already specified that these fields must have a type, and the way we specify this type is via a template parameter for each of these fields. I've actually made a small typo here, but not to worry, I fix that soon enough. Seeing that these are static class members, we also need to give them a declaration outside of the class definition. Since we want these fields to be associated with our table, what we need to do is pass a pointer to that table in each of the field's constructors. So, to summarize what we've done so far, what are we actually doing with all this code? Well, it's actually so important that I'm going to be writing it in this big comment block here. What we've just done is created a table object, and we've called this data table. Our table has two fields, and we named these fields A and B. Our field A has elements of type integer, and our field B has elements of type float. And there we have it, a nice simple data table in C++. Of course, what use is a table if we can't store anything in it? To insert a row in our table, simply call the insert method of our table object. This method returns a size type value representing the ID of the row that we just inserted. No matter what wacky things happen to our table, our rows should always be uniquely identifiable by this ID. If we want to set the elements within this row, we can simply do that field by field. The syntax here means, for the row with ID X, store the value of 69 in the field A. Similarly, for the field B, in the row of ID X, store the value of 3.14. Note that with this syntax, we are referencing the elements by their row ID as opposed to the row index. By row index, what we mean is its actual position within the table, as opposed to the label that is given to it upon the row being inserted. In general, the row index and the row ID are not equal. We can insert as many rows as we like in our table, and we can assign the elements in any order we please. To check assignment has worked as expected, we print a row to the console. Naturally, this means that we must include IOStream. We compile our program in the usual way, and I run it to see if we get the output that is expected. And we do! Our fields A and B for the row of ID X are showing values of 69 and 3.14 respectively. Let's now take a closer look at the IDs of the rows that we are inserting. So here I am printing out the value of the ID X and the value of the ID Y. Compiling and running the program, we see that X and Y are 0 and 1 respectively. Since tables are filled from the top going down, in this case our row IDs correspond precisely with the row indices. This, however, isn't always the case, as we shall soon see. To demonstrate the current coincidence that we have between the row IDs and row indices, we can print the row of ID X alongside the row with 0 index. We'll see that they give equivalent lines in our standard output. We take this opportunity to note that whenever we use the round brackets, we are referring to an element by its ID. When we use the square brackets, however, we are referring to an element by its index. The coincidence between the row IDs and the row indices goes away once we start doing things such as deleting rows. If we delete the row with ID X and then decide to print the row of index 0, you'll find that we do not get results that correspond to the row of ID X. We instead get the elements in the row of ID Y. When the row of ID X is deleted, what happens is that the space in memory that row was occupying is taken up by elements of a row that was at the bottom of the table. This is how row IDs and row indices can get mixed up, and so in general we can never assume that they are the same. As of now, that's just about everything DOP-C has to offer. However, I do believe that this is enough for DOP-C to be a competent solution for column-based data tables in C++. You can insert rows, delete rows, and arbitrarily modify the table elements. It is my hope that this library can be used to build some pretty cool data-oriented software. Thank you for listening.